This question is a question that is identical. Numbers have changed. The idea is identical to one that we did in section 6.1. The only difference now is instead of answering between negative 360 and 360 degrees, our answer is between negative 2 pi and 2 pi radians. And instead of saying solve to the nearest tenth of a degree, this one is saying solve to the nearest tenth of a radian. So everything that we've done with degrees, hopefully you're really, really good at all of your trig with degrees, because we're going to redo all of that trig again and just substitute radians instead of degrees. So our calculator is going to have to be in radians instead of degrees. Our thoughts are going to have to be in radians instead of degrees. But the ideas stay the same. So this is a triangle question. We've got the point negative 4, comma 3. So if we draw that out, negative 4, comma 3 is here in quadrant 2. We can draw that back to the origin, and this would be an angle in standard position starting from here positively. This could be a negative standard position. Either way, we can draw our triangle and label our reference angle here. In this triangle, we know that this length is 4 and this length is 3. Notice when I'm talking about that triangle, I don't include negatives because I want you to think about that as just a regular triangle to figure out your reference angle based on the math that you learned in grade 10 and 11 about trig. With that triangle, if I want to find that reference angle, would I use sine, cos, or tan? I would use tan because I know the opposite side and the adjacent side. So I could write that tan of my reference angle is equal to 3 over 4. And if I wanted to find my reference angle, I would go tan inverse of 3 over 4. And I'm doing everything exactly the same as I would in degrees. The only difference now is when I hit mode, I make sure that it's highlighted on radians. And so when I go second, tan inverse of 3 divided by 4, my answer right now, 0.6435, is not something that I'm used to. I'm going to write it down. And we're supposed to round to the nearest tenth. Well, 6345, is that what it was? 6435. There we go. That feels a little bit different, right? Our reference angle is always between 0 and 90 degrees when we're in degrees, and it's always positive. Now that we're thinking in radians we have to think of it as between 0 and 1/2 pi. So what's pi? Pi is 3.14. Take 3.14 and divide it by 2. That's 1.57. Is this answer between 0 and 1.57? Yes. So it is a legitimate reference angle. Now, to find all of our answers, when I've got a domain between negative 2 pi and 2 pi, I personally like to, with my diagram, split it up into positive angles and negative angles. So from negative 2 pi to 2 pi, if we're thinking about the positive angles, can you see that starting from here, 0 to 2 pi is once around the circle, and this would be the only positive answer. Now, how do we write that angle? Well, if this was degrees, and let's say our reference angle was 30 degrees, how would you figure out what that green angle would be?
180 minus 30.
You do 180 minus 30. It's the same thing here, but what are we going to use instead of 180? We're going to use pi. So this angle will be pi minus our reference angle. And since we're going to be using our reference angles a fair bit in this question, you can either retype all those numbers all the time, but a really helpful thing on your calculator is the store button. So right above your on button is STO, sto, and that allows you to store an answer as anything you want. There's a whole bunch of letters on there. I always choose X because it's the quickest. Sometimes if I'm storing more than one thing, I pick A, B, C, D, E, F, G, whatever. Okay? What you can do as a joke on your friends is you can store the letters of your names as all ones and choose one letter to be a 10. And you can show, because most letters, if you've never stored anything on there, will be a 0. So you can type your name into your calculator and push enter and say, oh, I'm a perfect 10. Then type your friend's name in and they'll probably come up as 0. So now what we've done, we've stored that reference angle as x, and now I can go 180 minus my reference angle would be degrees. So in radians, I do pi minus my reference angle, and I can just push x, and I figure out that that green angle to the nearest tenth is 2.5. Yeah, if you've never stored something as x before, it will start off as x equals 10. Now we need to also find, because we've just done our positive angles, but our domain was from negative 2 pi to 2 pi. So now think in the negative direction, that would go from 0 to negative 2 pi. That would include this angle.
So it would be pi plus.
And if I was thinking in degrees, I would have done 180 degrees plus my reference angle. So thinking in radians, because halfway around would be pi, I'd go pi plus my reference angle, and whatever answer I get, I'd make it negative in the end, because it's a negative angle. So go back to my calculator, I go pi plus my reference angle, which is stored as x, 3.8. So this negative angle will be negative 3.8. So again, this is identical to what we've done in degrees. We're just doing it in radians now. For part B, we had one like this in degrees. Don't know if you remember, but the very first thing that we did, because it's cotangent and we're not as familiar with cotangent, if cotangent of theta is negative 2, then tangent of theta is negative 1 over 2. Notice the angle didn't change. It's the ratio that gets flipped. And if I have this, how do I know what quadrants it could be in? We could go to our cast rule. It's going to be in quadrant 2 and quadrant 4. Because it's negative. And tan is opposite over adjacent. So if I label these lengths, and I label my reference angle, which will be identical in both of those, because those two triangles are identical, I have a triangle. Now, when I'm figuring out the reference angle, so even though we have tan theta equals negative 1/2, when we solve for our reference angle, we always use the positive values because we're thinking of an actual triangle to find an actual positive answer. We go to our calculator, tan inverse of 1 over 2, 0.464. Again, just like before, I'm going to store that as x so I can save it for some more math. Now the question is asking, determine all the values of theta. So in the positive direction, can you see we'll have 1 here and 1 here. In the negative direction, we'll have 1 here and 1 there. Bell's about to ring. I'll quickly write these answers down for you. So the positive direction, can you see this first one would be pi minus your reference angle. This one would be 2 pi minus your reference angle. So to the nearest tenth, 2.7 and 5.8. For your negative ones, 1, -1 will be negative your reference angle. If I round 0.46, I'll get negative 0.5. The other one would be pi plus your reference angle. 3.6. Oh, hey, 13 and 14